to Advanced Physical Science. This is our 1.3 video. I want to walk you through this one particular problem in as many facets as I possibly can. So you're given a problem: what distance in meters will a car travel if it travels 65 kilometers per hour in 180 minutes? So the first thing we need to do when we're given any word type problem is do a TÜV chart. So the first term we come across is distance in meters. Okay, then it travels 65 kilometers per hour. Well, if I need the distance in meters, that means I've got to move this into meters per second in 180 minutes. And again, if I'm given minutes, I need to convert that into seconds. So these are the things that are given in our problem, and I'll highlight them so that you know what was given. And then we need to actually fill in the rest of it. So this is looking at velocity, and this is looking at time. So our variables are x and x naught. And again, we do like to put that down into tiny town. And then v and t. So our equation down here that ultimately we will be using is kinematic simple. X is equal to x naught plus vt. And again, put the naught down into tiny town. So the x is what we do not know. That is the distance that we are traveling. The x naught, and again, be sure you come out of tiny town, is equal to 0. How do I know the x naught is equal to 0? Well, since I'm not given a starting location, I can only start from where I am, which is nowhere. The velocity is at 65 kilometers per hour. So the first thing that I need to do is come down, and I can go way beneath my problem. I can go in the middle of my problem. It doesn't matter. And I need to convert. So I need to insert a table to do a conversion. And I don't know how many things I'm going to need, so I need to figure it out. So my kilometers will turn into meters, and my hours will turn into minutes, which will then turn into seconds. So I need kilometers to meters, that's one, hours to minutes, and minutes to seconds. So I need 3 conversion columns. So if I start with my 65 kilometers per hour, I can then put my, and you know what, I do need another one. I can put my kilometers on the bottom, right? 1 kilometer is 1,000 meters. Then I go and grab my hours. 1 hour is 60 minutes, and 1 minute is 60 seconds, because I have to be able to do my conversion. Now, I'm going to actually open desmos.com/scientific. The scientific calculator is way better than the graphing calculator for anything other than graphing. So looking at my problem, I have 65 times 1,000, 65 times 1,000 divided by, but that's not where I really want the division, is it? So watch carefully. You can actually make a fraction in Desmos and do 65 times 1,000 and then 60 times 60 on the bottom. And that will give you, and we're going to round to 3 decimal places, 18.056 meters per second. So this is actually 18.056 meters per second. Then finally, the time that I'm given in the problem was 180 minutes. But I really want that to be in seconds. So again, I can do another conversion. inserting a table, and my 180 minutes, sorry about that, my 180 minutes can turn into seconds because 1 minute is equal to 60 seconds. Notice the top and the bottom. So 180 times 60, right? 180 times 60 is 10,800 seconds. So 10,800 seconds is really the calculation that I need. Okay, so once I have those values, and I am going to pick these up and move these way down here to the bottom so that we can actually see our EWA and our x equals equation. So x is equal to x naught plus vt, right? So since I'm trying to find x anyway, I don't have to use a rewrite of kinematic 1. I can just use kinematic 1. So x is equal to x naught, which is 0, plus v, which is 18.056, times t, which is 10,800. All right, so back to Desmos we go. 18.056 times 10,800 is, and we can literally copy and paste that beautiful answer here. And that would be in meters. Now, our x equals equation would go with our xt graph. And I don't ask you to give me the xt graph. I just want to know what the equation of that would be. You take this base equation here, and you simply replace your x naught and your v. So this would be x is equal to 0 plus 18.056 t would be the equation of the xt graph. And then the v equals equation would literally just be the velocity again. V is equal to 18.056. Notice I'm using the converted values, not the original given values, and that's vitally important. You want to be sure you put everything in the problem back to base values. Hope this helps you do today's assignment. Thanks for watching.